Hi everyone, welcome to Tech Talk, a podcast where we talk about various technology-related topics and just deep dive into a topic that we've chosen each week. Today is a special episode because we have a very important guest with us today, Michael. He is a consulting software tester and a testing teacher who helps people to solve testing problems that they didn't realize they could solve. Michael has 25 years of experience in testing, developing, managing, and writing about software. Currently, he leads Developsense, a Toronto-based testing and development consultancy. In 2006, he became co-author of Rapid Software Testing. Since then, he has flown many countries, 35 countries on all different continents, and helped many people understand testing and also implement the rapid software testing methodology. Thank you very much, Michael, for joining us today. Very pleased that you could join us today. As you guys know, that I'm more into automation, but Amit has years and decades of experience in testing. Amit, I'll let you start off the conversation.
So thank you so much, Michael, for joining this podcast today. My first question, and that's always, I think it's one of the best questions, is what is testing? Before we get into rapid software testing, I just wanted to understand what is testing.
Well, you've been a tester for a long time.
Yes.
It's always a good question. I learned this from a journalist recently that the simplest questions are sometimes the most revealing. So it's a good question. We think of testing as learning. Testing is learning. Testing is evaluating a product. In the form of software testing, it's evaluating a product by learning about it. Now, how do we learn? We learn through experiencing things. We learn through exploring things. And we learn through experimenting with things. That's how kids learn. If you watch kids, especially the really little ones, the ones who are learning fastest are the ones who haven't been to school yet. They haven't been told how they're supposed to learn.
Of course. Trial and error, of course.
Well, a trial and error, but trial. Yeah. Trying things is really important. And of course, error, making mistakes, that mistake that you make, especially if you get some feedback on it, tells you not to do something, or it tells you to suggest that you do something in a different way, if you think of it as an error. That's how we learn stuff. We try things. Now, it's always interesting to me that a lot of that stuff gets left out when people are talking about testing, but it seems to me that's fundamentally what testing is. Testing is trying things. And those experiments in a software testing context would include observing the product, manipulating it, performing little experiments that involve navigating through it, seeing what's there, seeing what's missing. In a software testing context, we pretty quickly start moving towards evaluating risk. We're trying to evaluate the product and evaluate the risk associated with it. And that means for me anyway, it means focusing on problems. We've got to focus on problems if we're testing software, because the problems are there. You both have been programming for a long time, I imagine. And you know that in whatever program you write, there are problems.
Yes.
And
yes.
Humans.
Inevitable, yes.
Yeah. Well,
no matter how good we think we are, it will always be.
Well, sure. Not just that, though. Not just because of our propensity to make mistakes and coding errors and misconceptions and so on. But there's something else, and that is that a piece of software is not an intrinsic thing. It's not an object. But even this is true even of objects. It represents a relationship between people. I first became aware of that kind of notion working with Pam Kainer back in the earlier 2000s. That software is a communication among people. It's something that bridges the communication between people. It's a medium. And as such, there's a relationship on either side of the software between the person creating it, at least, and the person using it. And when we think about errors in programs, sometimes we usually think about errors in terms of the mistakes that a programmer might make. But there's also a room for a misstep, a problem in the relationship between the software and the person using it. And what that means is that a program that perfectly conforms to the programmer's intentions, the programmer's models, the programmer's desires, might not conform to the intentions of the people who are going to use it. So,
yes.
Go ahead.
Yes, no, absolutely. I mean, contextualizing, I think, to be honest, I actually didn't know about rapid software testing before, Amit showed it to me. And then I was doing some research, and I was reading your website. And one of the things that I found very fascinating is contextualizing. And this is, I imagine, what you were talking about right now, that contextualizing to the user. Because the programmer is obviously programming and they're thinking in one way, and the user would probably be using it in a completely different sense. I mean, I remember a joke which basically says that a man walks into a bar, orders one beer, orders 999 beer, orders a number of different things, orders minus one beer. And then and then another person walks into a bar and walks into the bar, and then they asked the bartender where is the bathroom. He goes to the bathroom, and the whole bar explodes because obviously the tester tested all of these different scenarios of ordering one beer or different drinks, but they didn't test what a regular person might do is go and use the bathroom. So.
What's always interesting to me about that story, and it's a joke, of course. I have been studying jokes for a long time. My first job out of high school was at a comedy club, stand-up comedy club here in Toronto. And the funny thing about that joke is that the tester, after a tester goes into a bar and orders a beer, there's something left out in that joke, and that is the tester never evaluates the damn beer, right?
Oh, right, of course.
How is this a tester? That's not a tester. That's like some kind of weird machine that goes in and orders all this strange stuff. If the tester's not evaluating the beer, two things are bad. One is the evaluation never happens, and of course the tester doesn't get to drink any beer, which is why I would go into a bar.
Absolutely, yeah.
So the sense of evaluation is missing. And I think it's I'm glad you sort of brought that joke out in a way, because every joke affords the opportunity for an epiphany, right? That's what jokes are about. They're the whole premise behind a joke is that it is reframing something. It's like you're seeing something in a different way. So if this is the first time I've sort of gone into that part of the joke in my own mind, and it suddenly occurs to me that so much of what people are doing in testing these days, so much of what is called testing, is based on doing stuff and not on evaluating stuff. We have a visitor here.
Oh.
The dog who is coming in to test to see whether there is any food.
What kind of dog?
It's a somewhat surprisingly, it's a golden doodle. It's a cross between a golden retriever and a poodle.
Right.
But Mom was golden and Dad was black, so it's a black golden retriever.
Oh, I haven't seen that before, actually.
No, they're around. Sometimes people call them golden doodles. Anyway, so after that brief interlude, the evaluation part of testing is what's really important. And while we're pulling on that thread, we might as well keep pulling and see what else unravels. It's not just about providing input to the bartender. It's, as you say, contextualizing what comes back. Because what comes back might be a kind of beer that you like.
Yes.
But it might not be a kind of beer that somebody else would like. And so what a really good tester does is a really good tester frames who this is going to be a problem for if there's a problem.
Right, yeah.
Because something that is working just fine for somebody might not be working fine for anybody else. That's the relationship part. And a really good film critic will allow that a film that seems terrible to some people might be just fine. Lots of kids lots of films that kids like, adults won't like. So you make that explicit in your review of the film that this is a film for kids or kids of a certain kind of attitude, certain kind of set of preferences. And then you can write a worthwhile film review, but just to say that it's a terrible film leaves something out. It might be a really good film for somebody, and it might be a terrible film for somebody else. So that's a much richer notion of what testing is all about, rather than just providing input to something and hoping that that a beer comes back and the bathroom doesn't blow up.
Absolutely. I mean, tailoring the output to target audience, that is so critical in everything that we do in technology, really. I mean, to be honest, contextualizing is one of my favorite words. And I mean, I overuse this word whenever I go in any interview, because if I can't put myself in someone else's shoes, be it the user, be it the software developer or the project manager, by doing that, I understand where they're coming from. Whichever role I have, it might be whatever the other person's saying could feel like ludicrous to me, but then only after contextualizing, only after empathizing.
There you go.
Can I only understand that where they're coming from? And a lot of the times, the bigger picture is not clear to individuals, but someone who is, maybe the user or maybe the project manager understands the bigger picture, and they might be saying something or driving the project towards a certain direction, knowing the bigger picture. But as a software developer or a tester, I might not be able to see the reason, and the direction might seem like it's not worthwhile. But that's the time when you should really ask a lot of questions, communicate, and again contextualize to realize what it is that is going on underneath.
Yeah, absolutely. And a lot of testers, it seems to me, can fall into that trap. It's easy to fall into a trap where somebody is saying this is a terrible program, or this is a terrible problem in this program. And well, that's a perspective. That's not a property of the program. The problem is not a property of something. It's a relationship between something and someone, or someone and someone else. So that it's easy to lose track of that. It's easy to get in your head as a tester. Certainly, I've done this lots of times. Seeing a problem that's really important to me, and not recognizing that for the people who are going to be using the product, maybe it's not such a big deal. So an immense part of the tester's job, and it's one that is overlooked across the board, it seems to me, is immersing yourself in the world of the user. And not just talking about it, and not just referring to the user as somebody who might be using the machine, but somebody in particular who might be using the product for some purpose, such that the context of the behavior of the product and the context of the problem that we're observing gets related to people who are actually intended to use it, as opposed to just being some kind of declaration that this is bad, this is wrong. It might be okay.
Absolutely. I think this actually sometimes creates a problem or a rift between developers and testers, because testers are actually just trying to identify issues with the software in terms of how it's going to be used by someone else, and just identify them. They are actually not trying to say it's a good work or a bad work, especially for a developer. Because me and Rinat, we worked together on a project, and Rinat was developing the UiPath code, and every time I ran the code I found an issue. And Rinat is like, oh, the requirement was not there, or maybe I did not understand it correctly. And every time there was a bug, we used to go back and forth and discuss about why it was not developed, and how it can be done better, what can we think about it. So I think it's very important to think about that perspective also, because a lot of it is very subjective. It is what I think, it is what someone else thinks. So it's again a question of who's testing, who's developing, who are they developing for. So that's where we have the personas. In testing, we wear a different hat. So suppose it's a non-technical person, how would they use this product? If it's a technical person, they understand all the settings, how would they use a product? A simple example was the URL that I shared with you for scheduling this interview. In my head, I thought you would understand, but when you tried to use it, you came up with a different outcome, and you said, Amit, I can't do this, I can't do that, I can't understand the interface. So it was again a very different perspective which I had not thought about, and it was a very simple thing, but I mean, in a completely different way, it was interpreted completely differently. So it was quite fascinating, just that simple scheduling link.
Yeah, there's no better way to get perspective on something, a different perspective on something, than to get somebody else to take a perspective on it. Yes. And now you're referring to a little schedule sharing thing, a timetable sharing thing. And my recollection of it was a couple of weeks ago, so I don't remember the details. But I think you were telling me that you had chosen, you said, pick something from this range of dates. And I think the range of dates in question had already passed. Well, okay, I'll go back in time and we can schedule the podcast for then. But then I tried to advance the clock forward on that. And all of a sudden, the option for my time zone disappeared.
Yes.
Now, how did this come to be? Well, my imagination, and I don't have a way to back this up, but my imagination is that it was developed in one place, and it didn't receive extensive testing from somebody in another place, or maybe any testing at all from somebody in another place. So there's a push for diversity in testing. And I think it's a really important thing to have. We need as many perspectives as we can get.
Yes.
And those perspectives are not just based on our gender or our skin color, which, by the way, is the most absurd use for classifying people. It's the amount of melanin in your skin. It's just stupid. But we need diversity on cultural backgrounds, which are different and are significant. And we need diversity on roles in an organization of the people who are using it, as you were suggesting, Amit, different kinds of people. But over the last several years, I've become more enthusiastic about this idea, and I wish more managers, more organizations, and more testers were pushing for this. And that is, if I really want to understand how somebody's going to use something, I must be in their world. I must live with them for a while, like an anthropologist would, and hang out with people who are doing that work. Now, if you've got a social media app, everybody's using one of those, right? There's not a whole lot of really important cultural differences there. But if you're a tester who is placed into a financial context, if you big money, or if you're working on a medical device, I think that it's really important somehow, and it's logistically challenging, but it's really important to immerse yourself in the world of people who are doing medicine, who are doing finance, and to hang out with them as they actually do that work. Now, immediately I can see pushback coming from management who says, "Well, that's expensive. We don't have time for that." Well, yeah, what's the rush? I mean, do you want a product that fits for those people, or do you not? And the consequence of all this is in the medical records field, for example, very famously for this. If you talk to doctors and nurses and administrators, you just look at what they say about these things on the web, in magazine articles, newspapers, you'll find out very quickly that they hate them. They hate these patient record systems because they don't fit with the work that these people are trying to do. They're not convenient. They're not set out. They're not free form enough. They're very restrictive. So what happens is that patient care starts to look like the work of computers and not like the work of doctors.
Right.
Nurses.
It's very interesting you raise this point because we have NHS, the National Health Service in the UK, and whenever we go to our GP, the general practitioner, they open a piece of software and they start typing things into it. I never actually thought about the user interface behind that particular software, but I'm guessing that yes, some software person and some software consultancy must have designed it, and they would have enforced it on all the NHS health workers, and now they are restricted to using that piece of design. And actually a lot of companies are trying to disrupt that market, but it is very difficult to get access to that particular system and replace it because there is a lot of knowledge in that system and the way it's used, who uses it, how it's being used, etc. So it's very interesting you raised that point. But software is anything that can be used to control machines, and in this case we are we have software to do things and different types of things. So you gave an example of say doctors using the patient record system, but there are softwares, say the Mars rover that is using, NASA just sent a rover to Mars, so that's being controlled by software. And then we have software that controls industrial machines, and then we have softwares, the regular software that we use, the websites, the Microsoft Office, operating systems, etc. So when we talk about testing software, so rapid software testing has software in it. So what kind of software are we talking about, and does that method or does testing apply to all kinds of software, or do we have to approach testing different types of software differently?
Well, when you say that software is being used to control machines, when you're saying that software, for example, is being used to control the Mars rover, that's true. But what's the Mars rover doing?
Mars rover is, yeah, I mean, it's performing some actions based on, so the software is taking inputs through what the sensors are taking. It's evaluating those inputs, and then it's trying to give an output. That output might be sent to the hardware, and the hardware then does some action.
Okay, so let me offer an interesting distinction that I came upon recently, and it comes from a fellow that we've been talking about quite a bit in RST over the last few years, because he's been very influential on the way we think about this stuff. His name is Harry Collins. And Harry points out that computers and their software themselves are machinery, ordinary machinery. He talks about these things in terms of, pardon me, I'm being familied to death here. There we go. He talks about software as being mechanical and points out that the earliest computer that we call anything like a computer itself was mechanical. It had wheels and cogs and so on and so forth. So they're machines, but he says they're also what he calls social prostheses. They fit in the space, a social space where a human once fit. Or, if you like, I would offer where a human with superpowers could fit, certain kinds of superpowers, the ability to do calculations really quickly, or the ability to control a number of machines simultaneously. Well, deciding whether the prosthesis, like in a medical prosthesis, the body around the prosthesis has to adapt to the fact that the prosthesis doesn't do exactly what the human pancreas would do in case of an insulin pump, or what my brother has no arm from here down, and he wore a prosthesis on his arm for a long time. He stopped doing that for most purposes because it didn't do what he needed an arm to do. He wasn't able to, Harry's word is repair the difference between what this machinery should do or what the prosthesis should do and the thing that it replaces. So what's the Mars Explorer doing? Well, the Mars Explorer is still part of a system that has humans at the other end of it.
Yes.
The Explorer, people talk about them as Mars Explorers, but they're not doing the exploring. We are. And we're using these immensely sophisticated machines, right? Exactly, in order to effect our exploration. So, whenever we talk about machinery being used to control, software being used to control machinery, the end of the sentence is missing. The end of the sentence, it seems to me, has to include for what human purpose. Because whatever machinery is doing, it's always doing something for a human purpose. It has no intention. So when you said action, there's a very interesting distinction that I think is worth making, and I'm going to try to start making it or bringing it to the light of the testing and development community. A difference that Harry distinguishes between behavior and action. Where behavior is something that is observable and physical. You can see it. You can discern it. They're little catches to that there's some mental behaviors. There's a little bit of fuzziness in there, which I won't go into because it will complicate things a little bit. But an action, says Harry and his colleague, Martin Cush, is behavior plus intention.
So like
Right.
a conscious choice, a conscious decision. So you think about it and you act upon it. So an action. And a behavior could be unconscious.
Yes, and a nice way of thinking about it, I suppose, is to distinguish between a blink and a wink.
Of course.
Right, a blink is something that just happens. Right, here I am blinking my eye, but a wink has intentionality associated with it somehow or other. But what's interesting about a wink is that even though it's exactly the same action, the same behavior, pardon me, I'm messing it up myself. It's exactly the same behavior, but humans have the capacity to sort out the intention thanks to the fact that we're social agents. So if I go like this to you, it is an attempt to communicate, which we'll sort out in context. Like, I might be joking, so I wink, or I might be greeting you, so I wink,
Right.
or I might be trying to seduce somebody, so I wink, or I might be trying to signal, all right, we're okay. The plan's ready. Now we can jump the guards, right? All of these things can be imparted by a wink, which is physically but a blink, only a blink. So one of Harry's points is that machines behave. They don't act.
Right.
Whereas Rover behaves, but it doesn't act. The action part of it comes from us. The intention part of it comes from us.
From
merging, from the user or from somebody who has some kind of need or desire and has an intention to get something done. Now, there's a lot of nuance associated with that, but the basic idea behind it, I think, is it might be useful to remember that, especially in a day and age when people are getting very excited about what machines are capable of doing. They're not capable of forming intentions.
Yes, not yet.
Well, not yet, but I mean, what would they have to do in order to form their own intentions? Not an intention that is programmed into them, but their own intention.
Yes, absolutely. I mean, to be honest, then this reminds me of a science fiction I read when I was a teenager, and this was about how to make AI, so they can feel. And one of the ideas that the author was exploring was that what if an AI was made in a way that they're constant in a very constant pain all the time. So if they see something, and that could be a library of things, various things, which will give them a reduction of from that pain. So say, for example, if they look at flowers, that could reduce the pain very slightly, and that would translate to be, some sort of emotions or, feel good. And, obviously then from there, it can become, a very complex set of library of various things could make it have some sort of intention that it is always intending to reduce the constant pain it has. And
who put the pain in?
Well, that's the pain or discomfort or something that needs to be programmed in. So
we're right back to people again, right? We're right back to the human intention to model this in some way. So as long as we have people directing the construction and the programming of the machine, there will be people in the equation. another dimension of that, which is really interesting. And Harry is a sociologist of scientific knowledge, but he's one of the most interdisciplinary people I can imagine. For a long time, he's been writing about what machines and humans can do because he's been studying the nature of knowledge. And as a sociologist of scientific knowledge, especially, he's been involved in watching people build and construct machines of various kinds, lasers and gravity wave detectors, interferometers, and computer software for those things and so on. But what he points out is that, and a lot of people miss this, we say, oh, well, we can have artificial intelligence if we expose computers to everything that's out on the web.
No.
Yeah.
No?
Companies
Okay. I'm with you, I think, Rinat, but why? Just as I'm transpecting.
Well, I mean, it depends. I mean, I think I'm coming from a different perspective. I mean, I was when you say artificial intelligence, I was more, talking about general intelligence, where they are their own self, who can have intention or feelings or some sort of intention, to be honest. I mean, that's the general intelligence, isn't it? And that, I mean, obviously, I don't know whether it would be a good thing or a bad thing, but I kind of think that we're nowhere close to there yet.
But I agree. But what's the problem with showing the machine pictures of flowers?
Sorry, I'm not really. Of course, we can show. I mean, right now we have AI modules which will identify what is the picture that we're showing. Is it a car? Is it a dog? Is it a flower? But it won't. It won't feel the way we feel of when we look at different objects. Now, why? I mean, I think the question is, why do we feel the way we do? What is the nature behind that? And obviously, you could have evolutionary explanations behind it, and then ultimately we would all end up finding the reasons why we do what we do, and there will be reasons behind it, and then we'll realize that even we are not as complex that we thought we were.
Yeah, I don't know about that. I'm fascinated by that idea, and I'm with you all the way here. I agree. When you say it doesn't feel what we feel, I think that's really important because, for example, the machinery does not see a flower. It sees a pattern of bits, and it doesn't see it. I mean, when we see it, we're automatically using it. When we say see, we're using a metaphor there. But it doesn't smell the flower.
Yes.
It doesn't share the pleasure of receiving a flower from another person. No.
Right. Yes.
It doesn't have those kinds of social and cultural associations that we have with flowers. It doesn't realize the significance. I'm very lucky at the moment because just outside my window here, there's a crabapple tree and it's blooming. And it's gorgeous. It's incredible. And we've had a really long, cool spring here in Toronto. It's been much cooler than usual. Not so cold as to freeze the buds off, but cool enough to preserve them. And on top of all that, we haven't had a big windstorm or a big rain that would tend to wash the blossoms off. And I've been home the whole time, thanks to this terrible situation we're working with just these days. My wife and I go out in the back garden and we look around us and say, isn't this tree amazing? How wonderful it is, because it's always teetering on the edge of dying. How wonderful it is that we've got this tree. Well, it as you say, with the feeling, the machinery won't do that. And that's why, to bring it back to testing, that's why I think we've got to be super cautious about the beliefs that we have about what machinery can and cannot do in the field of testing, because machinery does not feel. It doesn't get frustrated. It doesn't get annoyed. It doesn't get confused. To the degree that it does get confused, it got confused because the programmer got confused. The programmer didn't anticipate a situation, and that's not a diss on the programmer. Lots of things are hard to predict, unpredictable, surprising, novel. Well, machinery just doesn't know how to deal with that. And that's one of the reasons that we are, at exactly the same time as we're enthusiastic about tools in rapid software testing, we are skeptical about them. They are not the royal road to getting testing done. They accelerate it and they intensify it, and they enable certain things to be very difficult otherwise. But they can't do the testing. Tools don't do testing. And it's crucial for us, I believe, to remember that. Because what tools do is they accelerate things. But they're agnostic about whether what they're accelerating is good or bad.
Right, of course. I mean, I see we keep coming back to the human counterpart of any kind of technology implementation, and that's
not a counterpart. It's not a counterpart, though. It's like the human counterpart to it's like saying that the human counterpart to a prosthesis is a hand. No. No, that's not the way it goes. The prosthesis is a stand-in. Now, that's not to say, by the way, that prostheses are fundamentally always in every way limited. For example, there are those artificial legs that have those springs at the bottom.
Yes.
And people who use them adeptly can run much faster than a human can. But the point is that they extend us, they intensify us. And so if we're doing bad testing, then software can help us do bad testing faster and worse than we've ever done it before. Right? It enables and intensifies whatever we are. So it's an extension rather than a counterpart. But I'm glad you brought that up because it's an important point.
Yeah, no, absolutely. I mean, to be honest, I was actually thinking about asking you about something else. So yeah, no, that's it's good to be clear on that. Yeah, it's an extension, not a counterpart. I absolutely agree with that. But what I was thinking is obviously we of course, the contribution or the role of human is at this point not replaceable. And what I was thinking is, I mean, my passion for standardizing things kind of brings me back to, okay, so we can't, we'll always have humans at the end who are, bringing the intent, doing the actual thing. But can we standardize the human I mean, perspective taking, we talked about perspective and how important it is and how different cultural background could give us different perspectives. But could we, in any way standardize it? I mean, humans, for millennia have tried to standardize or categorize other humans. For example, it started with, the astrology, which was obviously very stupid. But now in recent years there has been other ways to categorize human behavior in a way, like Myers-Briggs, where you get 4 letters to describe yourself, and then there is Discovery Insights, where you can be one of 4 types. You could be like do it now person, or the analytical person, or do it together person, that kind of thing. So could we in any way standardize human behavior from an user perspective that, that a tester can utilize to do various perspective taking. So, they would have like a list of, 16, 32, or even 100 different perspectives that there could be in any scenario. And the tester would sort of utilize that list so they can ensure that, I have tested for all different kind of perspective. Is it possible to standardize it?
Well, you practice something called robotic process automation.
Automation, yes.
Yeah. Well, it's possible to standardize robotic processes.
Yes,
I mean, that's the whole idea, right?
Yes.
That's the whole idea. The question is, do we want to make something a robotic process or not?
Right, okay.
There are certain things which I could quite easily tolerate being a robotic process. Let's see. The manufacture of something, when we want to make a zillion copies of something, makes sense to me if we want to have a consistent output from something such that the millionth copy of it is just like the first one, then robots could be a good way to do that. But the trouble is humans don't want that all the time.
Yes, absolutely.
Because what we're talking about with a piece of software is not the millionth copy. It's the first one. Right? That's what's happening when we're developing a piece of software. A lot of people want to turn that into a factory process. Well, that makes sense if we were producing the same piece of software over and over and over again, but we're not. We're always trying to produce a piece of software that solves some problem for some person and does so in a novel way. Now, the process of copying bits from one hard drive to another, or copying bits from, it's still one hard drive to another when I want to see a movie. Okay, I want to see a movie. And so I go to a streaming service, and the streaming service cheerfully supplies my computer or my device or my TV with a bunch of bits that represent that movie. And it's great that we can do that consistently. But here's something that still pretty much sucks pretty badly, and that is there is no software that I'm aware of that can reliably show me a movie that I like. Point me to a movie that I want to see right now. Now that it can. Maybe I want to watch a documentary, but my wife wants to watch a good drama. Well, there's no piece of software, it seems to me, that can square that circle. Because tomorrow the whole thing could be different. Today I want to see the drama, and tomorrow I want to see the drama, and she wants to see the documentary. Well, as soon as we involve human needs and desires and a social context, we can't automate that, and that's the real job of testing. The easy part of the testing job is the key punching. Yeah, we can automate key punching. That's easy. We can automate comparison of this particular output that is coming out of the program right now to that particular intended, desired, predicted output, the one that we wanted, presumably. But what we can't get software to do is to say, well, I wanted something different based on this little tweak in my preferences or in my needs or in my desires or in the situation or in the fact that this person is 2 meters tall and this person is 1.5 meters tall and clothes look different on them,
Right. Fair enough. I mean, you've presented a scenario which is quite complex to automate or for robots to sort of do or come up with the right movie that you want to watch. But I mean, to be honest, let me present you an opposing scenario where, for example, I mean, before I present the scenario, I mean, I'll tell you where I'm coming from. I'm coming from a place where I don't narcissistically think that humans are the most complex, thing that can happen. A lot of the times humans are quite predictable. So the scenario is, if I was to poke someone with a toothpick, there's only a handful of reaction you can expect. Maybe they will go ouch, or maybe they will just remain nonchalant. Maybe they will act out. Maybe they will, respond with their voice. There's only a few things that can happen, after that incident. Now, if you create a library of complex incidents of various things that happens and create order of what would have higher priority in a human in terms of, if three different things happened to them, someone talking to them and being poked at the same time, as well as maybe the TV is on. And then depending on what, the order of priority of that human, they will probably behave a certain way. And that is, theoretically is possible to calculate. So, if as the power of technology improves and we could do more and more calculation and we could have more complex libraries of, actions and responses to those actions, could we not eventually crack this code of how humans behave? And then from there, we could probably streamline or standardize the human reaction, and then have all kinds of perspective that there could be, and anticipate and program from there.
And then do testing.
Well, let me say one thing about that I find appealing, because I find much of it pretty unappealing. But there is one thing that I think in there that is very worthwhile. If we stop treating machinery as a controller of things, and start looking at artificial intelligence as a lens or a mirror into ourselves, I think it could be interesting. I don't want to put it in charge. I think that would be a terrible thing, on principle. And when people say, "Oh, wouldn't it be better if machinery handled this?" I think that is a sort of kind of hyper rationality that itself borders on a certain kind of narcissism. But there's a general systems problem associated with understanding what's going on in a human head, and that is we need something more complex than a human head to do that. And we wouldn't know what that was because that's what we've got. All we've got is human head. Now, there's something to be said as well for the fact that a bunch of human heads in collaboration forms a kind of superhuman power. Indeed, that's the whole thing behind testing, isn't it? That the perception of any person who's building a piece of software is limited to their own interior world. And so having another person's perspective is automatically going to afford a different perspective of some kind. Now, we want to be cautious to make sure that we're not limiting ourselves to other builders, or indeed, even with testing, other people who come from a software background. I think it's really, really important for the testing world to embrace non-programmers, non-technologists, and bring them into the field of testing, as indeed lots of companies are doing with social scientists and psychologists and artists and musicians and designers and so on. It seemed to me that in a way that the world of software is more fertile back in the days when there were fewer people who had gone to school for computing and computer engineering and so on. When the computer business was so desperate for people that they would hire, somebody like me who came from a theater background originally. I think that's all to the good. It's important to have non-builders in there. But if we're going to build some kind of if we're going to build AI, to use it as a model or a mirror or a lens for looking at how we think, well, that's sort of interesting. That's pretty interesting because on top of everything else, it prompts us to think about certain kinds of ethical things. The sorting out the trolley problem and variations on it and so on becomes much more real when you're putting it in, somewhere into an autonomous vehicle of some kind. But how much farther do we want to go with that? I don't, we're using computers at this very moment in a wonderful way. Helps us to chat with each other and talk to each other and so on and so forth. But I'm resistant to the idea that they should be going any further than we want them to go. That humans must remain in charge.
But Michael, I mean, if we take that same premise, so let's see, for example, Donald Trump was elected U.S. president through fair means, through public voting, but a lot of people in the general population didn't want him to be the president. Now, instead of Donald Trump, if we have someone, some AI, for example, which is non-biased, which doesn't care about what your color of skin is or where you come from, and or what sexual preference you have, and without any of those judgments, I then take decisions which benefits the majority of the people. Will that not be tolerated by humans? Because then we have something better than someone that we are actually elected.
Well, let me be the first to say that whatever mechanism that it might take in order to keep a Donald Trump out of office, I'm not going to turn it down.
I'm just challenging your...
Yeah. Okay, well, you had a key word in there, majority.
Majority, yes.
Okay, so as soon as you decide that the will of the majority will be followed, then you've got a new problem. And the problem is that the will of the minority may not be respected.
Agreed.
Okay?
Yes.
That's one issue. And the other issue is that we need the will of the minority.
True.
Right? We absolutely need it because otherwise the will of the majority prevails. And I mean, we're watching that play out right now in all kinds of situations. In today's news, you can open up and see how people whose rights have been trampled on. You can see how people whose needs have been ignored. You can see how people whose suffering has been pushed aside. Well, you can look at that and say, well, what's wrong here? I mean, the majority rule, right? Well, that won't do.
Yeah, I mean, always favoring majority might be counterproductive to a meritocratic society to begin with, because merit isn't always the majority.
Certainly not. I mean, Trump did get in 2016. Right?
Okay, so I mean,
but who decides is the question on the table, right? Who decides what's right? Who decides what's good? And that's something that is not subject to calculation. It seems to me, certainly not subject to an algorithm.
Okay.
Can't be subject to an algorithm because the algorithm, finishes. It's the nature of an algorithm is to finish. And the nature of an algorithm is always to get the right answer. Now, in a formal system, that's great. That's a wonderful thing because it allows us to solve certain kinds of problems that yield well to formal systems. But the world of humans is not a formal system. It's a social system. And that means that as soon as we start to apply an algorithm to that, there's a chance that the algorithm will come out, not just a chance, a certainty that the algorithm will come out with a right answer for someone.
Yes.
Yes. And
Yes.
I mean, in testing, we see that, right? So we have a tool which automates things. So people call it automation testing tool. So it's trying to execute certain things and then give a result. And based on those results, we decide whether we want to release the software or not. And we look at...
whoa. You missed a step.
Okay.
Based on those results, we decide whether we're seeing a problem or not.
Agreed. Okay. So
because there could be a problem in the test code, there could be a problem in the experiment that the test code instantiates, there could be a problem in the product. So we got to remember that. That's a really important point to not to leave out and to paper over.
Yes. So whether there's a problem or not, but in that case again, we think about have the majority of the bugs been fixed, and some bugs left which can be left ignored. So again, we are talking about majority of bugs in a list of say 100 bugs. We are talking about, okay, if all the major bugs or say 80% of the bugs are fixed, can we release the software with 20% of the bugs? Because I mean, we are not thinking about human beings here, we're just thinking about software bugs. And with that,
well, as soon as we stop thinking about human beings, we're in trouble. Because when you say 20% of the bugs, what's in those 20? What's in that 20%?
So in testing,
it only kills a few people. It's a medical device. Oh, we only off a couple of people. We fixed the 80% bugs where we.
No, it's a typo. It's a documentation error. It's the icon is not right color. Things like that. So I mean, I understand there is a human aspect to it, but from a software point of view, if we have to objectively think that, okay, can I release it or not based on the testing that has been performed, how do I decide that?
Well, what do you take objectively to mean?
So subjective is something that is coming from my own experience, and objective is something that everyone in the room can agree.
Everyone.
So like,
okay. What about the people not in the room?
Even they. So like,
even they.
We call the gravitational force to be of a certain strength on planet Earth in certain conditions based on a certain height. Objectively, we know the value, and objectively, anywhere on the planet or anywhere in the universe, we can conclusively agree that this value will always remain the same given these conditions. So that's an objective.
This is a really wonderful example that you chose. You happen to choose gravity because that's what Harry Collins studied for the longest time. 45 years, I think, he was involved in studying gravity wave physics.
Okay.
And there's an immense problem associated with that. And the immense problem is that as soon as you have somebody declaring, I've seen a gravitational wave, I've observed a gravitational wave, there's controversy.
Yes.
That's what happened in the 1960s or 70s. A fellow named Joe Weber said, I've created a machine that can detect gravity waves. And all the physicists said, no, you haven't. And he said, yes, I have. And they said, no, you haven't. And he said, why? They said, because your machine is not sensitive enough.
Yes.
Your machine doesn't, it shouldn't be able to capture a gravity wave based on the theory. Okay. 45 years of refinement got us to the point where finally a bunch of scientists who, by the way, having detected a gravity wave, waited 5 months to declare to the world. They all apparently knew that they detected a gravity wave within the first week or two. But it took 5 months for them to go through the laborious, exhaustive, and exhausting protocols for them to agree that they agree on something. Okay? Now there's still a few people in the world who will say, no, you haven't detected a gravity wave. So what objective means is we are no longer listening to objections or objectors. Right? So as soon as you've got a human involved in making the decision, one or more, then you've got something that is objective. Now, we can come to an agreement on this. So we would, but let's not kid ourselves. Astrology is objectively incorrect, right? Astrology just doesn't work, right?
Yeah,
I would agree.
I would agree too. But now we've got just recently in India, we had that situation where. Is it Kumbh Mela? Is that the pronunciation of
yes.
Kumbh Mela? Yeah, that festival happens every 12 years. Except it happened again this year because astrologers declared that it's not exactly every 12 years, So this was a kind of a sort of leap year, leaps backwards a year in order to line up, right? And of course, that happened during COVID. Now, try to tell. I think it's monstrous myself that we're listening to astrologers on how to make decisions about this festival, because you could have put it off another year, and very few people would have been terribly upset. But the astrologers were saying, no, it's got to be this year. What are you going to say to them? Because these are strongly held beliefs, and for them, it's real.
Yes.
It is absolutely a real thing. Your science, they will say to us, means nothing. We have the science. And there's a wonderful line, a fellow named Wade Davis, an anthropologist, who apparently was talking to a Tibetan Buddhist, who says, we Tibetan Buddhists don't believe that Western human beings have walked on the moon, but you did. And he says, you don't believe that we can achieve enlightenment in our lifetime, but we can. No.
Yeah.
So
enlightening.
This is not to be anti-science, right? I'm a staunch admirer of science, and my goodness, what it's been able to do to address the COVID problem is utterly magnificent. But another thing that Wade Davis said is that when we walked out of Africa, he says, along the way, humankind invented 10,000 different ways of being.
Right.
And I think that's just absolutely gorgeous. And we've got to remember that when we are in the process of saying, well, this bug matters and this bug doesn't matter so much. It's true for us. But let's also remember, as we're in a rush to release things, that humankind has survived something like 2 million years without your stupid piece of software, your manager. So, we can go another week probably. We're funny critters, we humans.
So you mentioned rush. So in a rush of software, and then in rapid software we have the word rapid. So now, why are we testing software rapidly? Because
we want to help people with the process of evaluating software in the fastest, least expensive way that still completely fulfills the mission of testing. The mission of testing being to shine light on the product so that people can see it for what it is. And of course, that's all goes... here comes the objective thing coming in again. But we try to help people make informed decisions about software by examining it and exploring it and experimenting with it and experiencing it so that they can find the important problems that matter expeditiously, as quickly as possible, in a way that makes sense, and so that they can make decisions about it, so that they can decide whether this is a problem that is important to fix or a problem that we can live with. As you suggested when you were talking about that 80-20 thing, well, it's not just the numbers, it's the significance of it. But if they decide that in that 20%, there's nothing that would destroy the value of the software or even limit it to people who matter. So we want to be able to do that quickly. And that absolutely involves application of tools, but it also involves having a rich set of ideas, a rich set of perspectives on what's going on in the project, on how to apprehend the product, how to look at it. So in RST, we have our own list of heuristics. Other people, of course, are welcome to have their own list, but our list goes to the structure of the product, its bits and pieces, the functions that it executes, the data upon which the functions act, the interfaces by which we get data into and out of the product, and by which we might observe and analyze and get output from the product and so on. The platforms upon which the product depends. Operations, that is how people actually use the product, how people take advantage of the functions, how people put the functions to work when they want to get something done, when the rubber meets the road. And time. So we have these 7 basic perspectives, and each one of those has still more depth to them. But we try to provide people with a rich set of ways of looking at the product so that we reduce the chance that we'll miss a problem, courtesy of not seeing the product from that perspective. Similarly, we have a list of attributes of quality for the product: capability, reliability, usability, charisma, scalability, security, compatibility, performance, installability, these being things that matter primarily to people who are going to be using the product and getting value out of it. But there's also development-related quality criteria: supportability, testability, maintainability, portability, localizability. Now we got that's a list of quality criteria. We encourage people, we practically require people to create their own. They can adopt ours, but then it's like adopting a pet. You've got to make it your own, right? Then we also have a set of means by which people can recognize problems in the product, and basically that amounts to is the product consistent with patterns of problems we've seen in other places at other times? Is the product consistent with our ability to explain it? If not, we suspect that there's a problem. If the product is inconsistent with some aspect of the world that we're aware of, that we understand, that we've got experience with, that the product is not modeling successfully, or that the product is not dealing with properly. If the product is inconsistent with its history, if the product is inconsistent with an image that the organization wants to project or defend, if the product is inconsistent with claims that important people make about it, if it's inconsistent with products like it in some sense. Now, that's where, by the way, test tooling comes in, because a test tool is an instance of a comparable product. We don't mean a competitive product when we talk about that. We're talking about something where a tool or an algorithm or a feature in some other product or a comparable product of some kind is inconsistent with the product we've got. We have reason to suspect that there might be a problem here. If a product is inconsistent with claims that important people make about it, with what users might desire from it, that goes back to the quality criteria that I mentioned before. If the product is inconsistent in or with itself in some sense, if the product is inconsistent with the intended and either implicit or explicit desires and intentions of the designer, the builder, if the product is inconsistent with standards or statutes or laws or regulations or protocols, then we suspect that there's a problem. And our goal in doing all this, in this sort of fire hose of little guide word heuristics, is to provide testers with the insight that if you've got a rich set of models and a rich set of data and a rich set of tools, then you are better positioned to identify problems that might elude us otherwise. And to the degree that we're seeing problems in testing these days, it is due to the fact that managers, developers, and testers all alike are limited in terms of the richness of their approaches and their models and heuristics for identifying problems. I mean, that's why problems exist, because we're not seeing the product from a sufficient variety of perspectives in order to identify those problems. So the skill that we're trying to teach people in RST is the skill of applying those kinds of heuristics, but also the skill of developing those kinds of heuristics to continuously enrich the set of stuff that we've got for identifying and describing and contextualizing problems.
Right. Okay. I mean, this has been a very insightful conversation. I mean, I haven't thought about many things after, before you explained with the analogies that you've used. It's very, very insightful, and a lot of food for thought to begin to do in the future. Absolutely loved this conversation. I mean, Amit, we are kind of.
I know, but I have a couple of questions for you, Michael, because it's very fascinating what you've said, and interesting to look at all the different aspects of looking at a software when we are actually testing. It makes sense. But then you have these agile principles and agile methodologies and waterfall methodologies. So where does RST fit into an organization where an organization is trying to deliver this software as quickly as possible in an agile way, in a continuous CI/CD fashion? Then how does RST fit into that methodology? Because then development is happening. There is pair programming. People are saying, let's shift the testing to left. Let tools do most of the testing. So where does RST fit in all of that? And how do you apply that in a practical perspective? It's easy to look at a problem from all the different perspectives, but then when it comes to practicality, how do I apply that, say, in an agile method of software development?
What's more practical than having a lot of thinking tools at your disposal?
Agreed, but
a lot of perspective. It makes it instant. Yeah. Well, time and cost. Well, okay, but compared to what? If I have an idea, let's say you're talking about shifting left. We prefer to say spread left, by the way, because we don't for a moment believe that it's possible for us to shift testing left such that we're going to identify all the problems in the product before they go into the build pipeline. That's crazy. Anybody who believes that will be unpleasantly surprised in fairly short order, probably. But we do believe in the idea of spreading left. So let's ask ourselves, in those development meetings where we want to be fast, let's ask ourselves some questions before little problems escape our notice and get packaged into a much bigger problem. So, for instance, in a planning meeting, we're in the process of designing software and we want to do it quickly. What's going to cost us time? Errors.
Bugs.
Things that we overlooked and things that we didn't notice. So let's ask ourselves in those planning meetings, let's ask ourselves at least these 4 questions with 2 little variations on each one. 4 questions are, what are we building? Who are we building it for? What could go wrong? See, that's the tester sensibility. That's why we're at the meeting, right? What could go wrong?
Yes.
And how would we know? That's the testability aspect of it. Okay, so ask those 4 questions and ask them continuously all the way along. And you can ask them as quickly as you like, but if you've got a rich set of models available to you, you will be able to target those things at the speed of thought instead of having to sort of look them up or to write a program for them. Okay, so then you perform this little shift. What else are we building? Who else are we building it for? What else could go wrong? And how else would we know? Okay, so now we've expanded our initial set of things. Who else are we building it for? There may be people we've forgotten, right? So we have to think who else. And there may be people that we don't want access to the product, like hackers. So who are we not building it for? That's the second shift that we make on that. The second shift is, what are we not building? Who are we not building it for? What could not go wrong? And how might we not know? So once you've put that kind of flexibility into your thinking, now you have a bunch of dimensions by which, at any time through the process, in the sprint planning meetings and that sort of stuff, obviously, but all the way through, if those are, I was going to say at hand, but it's more like at mind. If those things are present in your mind, then you can you at least have the chance of identifying a problem that would have escaped you otherwise. So the role of the tester is, I argue this strenuously. There are people who say, "Oh, testers have to accelerate the building of the product," and of course we have to accelerate the building of the product, but we do that in a different way from the builders, because the builders want to build stuff as fast as they can and as well as they can. And it's our job as testers to worry.
Yes.
Our job as testers to doubt. That's the service that we provide. And in fact, one of the ways we're talking about it these days is to say that builders and programmers connect the world of humans to the world of machines. That's what they do. But what testers do is we connect the worlds of humans and machines to the world of doubt, to the world of risk, to the world of problems, so that the team can build stuff more quickly and more powerfully. But here's the catch. It's really hard to wear 2 hats at the same time. I shall demonstrate. If you're doing that, you look kind of silly now, don't you? Right? I just happen to have 2 hats. And it's even harder, by the way, when one of the hats is a programmer's hat.
Yes, the 6 decision-making colors.
Yeah, I never thought of that, actually, I suppose, except there's no black on this one. It's very colorful.
Right.
But there's no black on this one, so you need the black hat. Oh, well, what a perfect metaphor. In order, there's 6 colors here, but there's no black hat. And the black hat is the hat for the world of doom, the world of doubt. The world where, things might not all be rainbows here. There might be a dark day ahead. So that's our job. That's our special job as testers. But that doesn't mean it needs to slow things down, except to the degree that maybe things are going too fast anyway. My friend, now the door won't close. There we go. My friend J.B. Rainsberger put it really wonderfully one time when programmers sometimes, he realized, were not being diligent or thorough about testing and checking their work. And they would complain to him saying, "Oh, you're creating all this extra work for us." And he says, "No, it's not extra work at all. It's just work you've been getting away with not doing."
Interesting.
So I'm all for doing things quickly and immediately. But here's something kind of important. You cannot write a program or a test script that will lead you to all the bugs in a product until you have got experience with that product in some sense.
True.
You cannot anticipate all the problems in a product. Many of those problems can be addressed in advance of encountering them, but some of them are going to escape your notice. So here's the thing. The kind of testing that we see a lot of organizations focusing on at the moment, and it's a good thing to do this, is what we would call shallow testing.
Right.
Now, that sounds like an insult, doesn't it? But it's not.
It does. Like manual testing.
Well, manual testing, I think, is I take issue with that, but that's another thread. Shallow testing is not intended to be an insult. Shallow testing is a good thing to do because it allows the programmers to go at maximum speed with reasonable amounts of discipline. Right? Programmers go quickly if they can do shallow testing to make sure that what they've just built is reasonably close to what they think they're building. If we're committing easily avoidable errors, we probably want to know about that. And by the way, when I say committing, that's a pun. Committing in the sense of making mistakes and committing in the sense of putting it in the Git repository. So if we're committing easily avoidable errors, shallow testing can help us prevent that. Shallow testing is inexpensive. It is not intended to find deep problems. It is minimally disruptive to the programmer's flow, and that's a good thing. So shallow testing is not an insult, but it might be a warning. Because as soon as you think of shallow testing, immediately, it seems to me, the idea of deep testing should come in. And that's where we try in RST to shine light on different kinds of testing that we would want to do in different contexts. That those 4 questions that I raised earlier, those are testing questions that we ask during the intention frame of something that we're building. Whether that, by the way, is a whole product or a story or a feature or even a line of code, we're forming an intention to build something, and those 4 questions in the back of our head can help us to get straight on what we might want from the customer, what we might want from the product. Right. Then we're building it, and there's a discipline aspect of testing where we're doing shallow testing to make sure that what we're building is reasonably close to what we intended, and is done minimally expensively and minimally disruptively. That's a good thing. There's a preparation or a testability frame where we're looking at the whole landscape and asking, are we doing things to make testing as fast and as easy and as non-disruptive as possible? Are we allowing the programmers to go at maximum speed while at the same time having at least some eyes on looking at the product in a deep way? Not on every build. You can't do that on every build. But every now and again, looking at some of the build and looking for problems that might have escaped our discipline. Because problems can get by even a very disciplined programming regime. Right? People make errors, and those errors can get buried. So at that point, we're looking for deep, hidden, rare, intermittent, subtle, platform-specific, and most of all, emergent problems that show up because we can get strange and surprising interactions between things that on their own are wonderful, perfect. But when we put them together, sometimes they behave in ways that we didn't anticipate and that we could not have anticipated until we actually experienced them. So the theme of rapid software testing these days is to make shallow testing deeper and to make deep testing cheaper.
Right.
I like that.
Okay.
Awesome. And making shallow testing deeper allows deep testing to be cheaper. That's a good thing.
Yes, absolutely. That is fascinating. So, yeah, I mean, this was an amazing conversation. I mean, I'm certain that our audience will have a lot of value and insight from this conversation. Thank you, Michael, for explaining all of these things to me and also putting up with my half then good counter arguments. But yeah, I mean, did you say you wanted to ask anything else, or?
I think that has been really insightful, Michael, because thinking about a product from so many different perspectives is actually quite important, because a lot of times we miss that, and if we can do that quickly, rapidly, then that improves the quality of the product, and that makes it better for the users, and it helps the company create a good reputation. So I think testers, I've been testing now for 14 years, and I love testing. I'm very passionate about it, and I feel what you said, that we are there to worry, we are there to ask what can go wrong. So we are there who are asking the questions, and asking the right questions are actually quite important as well. So as a tester, our job is to ask the right questions so that others can think about it and come up with a better solution. So thank you so much again for your time. It's been really enlightening, and I've been listening to a lot of your other talks as well. And what we'll do is we'll share all the links to your course as well on our video as well as the podcast, so people can join your courses as well. So thank you so much again. Do you have any message for our audience in the end?
Well, you summed up what I've been trying to say so very nicely. So thank you for that. Yeah, my benediction, if you like, I suppose, would be to remember that doubt is a positive thing in the end. Right. It looks like a pessimistic perspective sometimes for people to think that our job is to investigate the software for problems. And ultimately, it's an optimistic one.
Yes.
Because by becoming aware of problems before we inflict them on people, we can do something about them. So that's the optimistic message of all this fundamentally. So I'd like to say thank you to you, gents. This has been at least as valuable for me as it has been for you, and I appreciate the questions and the counters and the conversation. It's been really terrific. So thank you.